thanks for joining. So the question probably got is what we're going to cover today, what we're going to look over. So we've got 4 main areas that we're going to look into. So the first one is we're going to go over some key Nmap commands. Now, a lot of people know what Nmap is, know how it works, but there's loads of different commands in Nmap, and a number of those commands are really, really helpful. And there's a lot more to Nmap than just running a basic port scan. There's ways that you can speed up scans. There's ways that you can make the scans deeper. Use it like a Swiss Army knife sort of thing, so that when you're given a different scenario in a job, in a penetration test that you're doing, you can make the tool work in the way that you need it to. One of the two biggest challenges I've come across with Nmap is, one is speed. So a lot of the start of any kind of infrastructure test requires you to be able to get a picture of the landscape, and if you're waiting hours for a scan to complete, that can be quite challenging. Secondly, it's to do with being able to get the scan output in a format that you can use later on. So while it's great to have it in a command terminal, it's really much better to have the Nmap output in a way that you can pass it into other tools and use it to speed up the testing that you're going to be doing. Then we're going to look at 3 different areas of older services, and while these services are quite old, a lot of them from before the year 2000. They're services that still exist, and they're a core part of the CREST CRT syllabus. So what we find is a lot of people, who have come into cybersecurity post 2000 may not have had the experience and the exposure to things like old Berkeley R-Services, how to mount drives, back from 1990, and things like X11 Windows services. Nothing to do with all Windows 10. It's this X11's been around so long that Windows has nearly caught up with it in its version numbers. But looking at these kind of services, because for 2 reasons. One, they're part of the CRT syllabus, and secondly, they are things that you still do come across on tests, and there's vulnerabilities and issues with them, and old systems that haven't been retired, systems that need to be in place because the future systems built on top of them. So they still exist. They might not be as prevalent as they once were, but they're still a core part of the information technology. And whilst a lot of the sort of modern sort of online vulnerability hubs and areas where you can go and test your skills have a lot more modern stuff, it's sometimes quite hard to find the old stuff as well to make sure you can sort of cover all the area of cybersecurity. So let's start with a bit of port scanning. Ultimately, let's start from behind a little bit in terms of what is a service. So does anyone want to give the answer? What's your definition of a service in the context of a computer system?
Something that runs in the background.
It definitely runs in the background. And what's its purpose, Kieran? What's it there for?
I'd say just to wait there until something sends the information or wants to trigger it.
Definitely, yeah. So it's kind of like we have servers, we have computer systems, and when you're browsing the internet and you connect to a web server or you're sending an email, you're interacting with a server, and that server, might have multiple different purposes. It could run email and web server at the same time, and services basically run on a system, and they sit there and sometimes they wait to be contacted to provide a service to the user. So the analogy that I'm sort of going with here is if you think of a city in medieval times, where inside the city there would be lots of shops and services that people might want to come into the city and use. And but the problem is, in medieval times, cities were always under siege. Cities were always being attacked by people, much like servers on the internet. So you have to build walls around them and stop people just coming in and taking everything. But you still need a way for those services that you're offering to be accessed, to be used. We're trying to balance the security without making it too available. So what we end up with is this concept of services. Services could be a web server. So Apache web server would run a HTTP service, and that would run on a port. The port would be the equivalent of, let's say, the doors and the gates in this city, and that would allow them to sort of come in and, I want to come in on port 80 and interact with the web service. So what we would do then is the server needs a way to offer up that service, and differentiate it between a web server and maybe an FTP server. So while we have loads and loads of services which run on different ports, we have Echo on 7, Netstat on 15, SSH on 22, Telnet on 23. We need a way that these services can be interacted with, and that is through the ports that are available. Windows also has services, just like Linux as well. But as I say, the entry is required for these. And the way that we provide that is through ports. So all our servers have different services running. Some want to be exposed, some do not. You're going to have some services that are internal and never want to be exposed to the internet or exposed to the outside world or even just the local network. Then you're going to have services that you want to be exposed. And the difference here is making sure you only expose the services that you need to expose from a defender's point of view. From an attacker's point of view, either a penetration tester or a malicious attacker, they want to find services that are open and available and in essence probe those services and try to get in. Which is why moving on to Nmap is so important, because profiling that network and finding out what services and ports are available is critical to either defending your network, or if you're performing a penetration test, trying to get into that network and find vulnerabilities. So the two pictures I've got on the screen at the moment, we've got a castle, again, same analogy kind of as before. The castle wants to be secured, but you do need a way to let food in, to let goods in, let people in and out. So you would have certain gates and potentially windows and things open, and they would be access points and egress points to get into the castle. A bank as well. This is my bank blueprint. I don't know if anyone recognised it from the Payday games. But this is basically, a blueprint of a bank, and the same concept would apply. It's if you want to secure something, take a server, put it in concrete, and throw it to the bottom of the ocean. Great, but you can't use it. So you need to be able to offer ways in and out. And this is where our services and our ports come in, which is why again the Nmap is so important as a tool. So ultimately, what we're looking at is a situation like this. We want email. We want to be able to provide email to our staff. So we run an email service on a server. That's great, but there needs to be a way for other computers, other devices to access that email service. So we open an email port. In case this could be port 25 SMTP, Simple Mail Transfer Protocol, and this allows people, other devices to connect to port 25 and interact with our service. So that's good because it allows the systems to function. It also now means that we've presented this as an opportunity, maybe somebody malicious, to interact with our service. So in terms of a penetration tester who's doing this legitimately, they're going to want to say, okay, port 25 is open. What can I do? Can I spoof emails? Can I read emails? Can I do things that I shouldn't be able to do on that service? And you end up with a situation where if you're given 100 servers that you're going to test, you're looking at all the ports that these servers make available, because every single port that is open and available is an opportunity, for a vulnerability to exist, for somebody to take advantage of that port, that service behind it, and the underlying system and the data. It's really just bringing that together to understand that, ports are so important, because behind ports run services. Services, they control, they run the data, they access the data, they access the internals of the system. So nice little pop quiz just to kick off. So here's some popular services and popular ports particularly. So what I was curious is, does anyone can answer me a few of these? What kind of services have we got running on these different ports?
Network time protocol.
Yeah, there we go. Network time protocol. Anyone ever use the physical classic phones? You can bring 1, 2, 3 and it'll tell you the time.
Yes.
Based upon that, yeah. Network time protocol, very, very nice little protocol that allows computers to sort of maintain time. Unfortunately, something as simple and nice as that has no real malicious purpose, gets used for denial of service attacks because it runs on UDP, which is connectionless. So what people can do is they can make a request for the time, but instead of putting their actual IP address as the source, they put somebody else's IP address as the source, and therefore I make a request, and that request gets sent to somebody else, and there are ways then to amplify that attack and do bad things. So this idea that, you know, some services, we might think of them as very, very important, like 3306 MySQL, you know, accessing a database. Obviously that could be potentially dangerous if someone took advantage of it, because if people can access your database, they can access a lot of sensitive information. But actually, even protocols like 123 could be taken advantage of. What about 20? I've told you 25, haven't I already? So that would be too easy. What about 20 and 21?
FTP.
FTP. Why do we have two ports for FTP?
Controlling data.
That's it.
One's a control stream with one's data stream.
Good man, yeah. So yeah, one is to basically initiate the connection and send sort of control commands. The other is to actually send the data when you are requesting or uploading an FTP sort of file. What about 445? This is one that features on a lot of penetration tests.
SMB.
SMB, yeah. So a core of particularly Microsoft's operating systems. It's how a lot of different sort of Microsoft servers and clients will communicate for lots of reasons, including file shares and things like that. So normally a big target. It's particularly interesting because Eternal Blue, you know, the whole situation around WannaCry, it was the core sort of port core service that was involved in all those unfortunate sort of incidents there. We've also got 161, sometimes a little lesser known. Does anyone know what 161 could be?
I do, but let somebody else have a shot.
Thank you, Ronnie. Anyone else want to throw down for 161?
I don't. I could cheat and Google it, but I'm not going to do that.
I appreciate your honesty, Carl. But you know, maybe if Google exists for a reason, doesn't it? You know, and as long as you remember it, that's the main point. So I'll give you this one. This is it's 161. It's SNMP, so Simple Network Management Protocol, and it can run on servers, but it particularly likes to run on network devices. And it's used to sort of gather information from network devices, routers, switches, and things like that. And again, it can come across as quite harmless, but again, given the right mindset and the right knowledge, you can use it to access the configuration of switches and routers, taking the configurations off of the switches and routers, and in some really badly configured situations, actually upload your own config. And that can give you an opportunity to move through the network to actually sort of jump from one area of the network to another as well. I'll do two more because they're the ones that we're probably going to be touching on today. Does anyone know what the 512, 513 and 514 set of ports are?
R-Services.
The R-Services, yeah, which I mentioned earlier. So these are the services from, I want to say, the 70s and 80s that, as I say, still exist today, which we'll have a look at how they can be used and misused. And we'll go over 6,000 as well. Does anyone know what 6,000 is typically used for? I was hoping, yeah, this will be the tricky one.
Yeah, I'm not answering this one.
Anybody else?
No clue.
Only because I've been fighting these same services for the past sort of week. So that's why they're so fresh in my mind.
The pressure you got, that's the point. If you don't use it, they very easily. Sometimes they merge as well into different. You remember one protocol that I couldn't normally by heart the difference between 512, 513, and 514 because they just merge into one group of ports.
Yeah.
But yeah, 6,000 is X11 sort of Windows service, and as I mentioned at the start, not to be confused with Windows as the operating system, but it's basically a service that allows you to log on remotely and see a window, particularly on Linux and Unix services. And again, if improperly configured, it can allow an attacker a way to actually view somebody else's desktop And it's the kind of thing that we do see normally internally on tests. So once we're inside the network and it's being configured legitimately, you know, there's a reason that people in maybe the IT department need to keep an eye on certain systems and servers. But again, like most things, if it's improperly configured, it can allow you an opportunity to gain access. So quick run of the answers. But again, the point here is just to demonstrate that the different port numbers relate to different services, and all those different services have their own vulnerabilities. One of the most challenging things, I think, when you do come into doing any kind of penetration testing is you start from a position maybe of not really having much knowledge of all of the different services that are available. You'll have some knowledge, potentially from the previous education or work experience, but you kind of have to learn every time you come across a different service, every time you come across a new area, you have to go down the rabbit hole and learn about it. So you come across NFS, Network File System. Okay, this is a protocol, it's available. What are the potential problems? What could go wrong with it? And over time, your knowledge increases and you develop it more and more. But it can feel sometimes, I think, a bit overwhelming at the start of it, particularly at the start of a career, when you see probably a lot of people that you work with, you know a lot about all the different protocols, but it's just time. It just takes time and sort of bit of grit. I remember quite a few years ago, I came across when Mongo database first came out. I came across it on a penetration test. Now, I knew about Mongo, I'd seen it working, but I'd spend a lot of time that evening after I came across that service for the next day of the test, you know, making sure I thoroughly understood what it was, how it worked, and how it could be sort of manipulated. So if you're looking to get into the area of testing, be prepared that initially you do have quite a lot to learn. I mean, there's always stuff to learn because technology always moves, but it's just one of those things that keep moving through it, and you'll get there bit by bit. Here's an example of an Nmap output of a machine that is very, very noisy. So what we've got here is we've scanned this machine here, 192.168.139.149. We're just in a basic scan, so it scanned 1,000 ports, and what we've got here is all the different port numbers. These are all running on TCP, they're all open. It tells us the service that it thinks is running on there, and the version of the service that it thinks is running on there. Now, this can be quite important because if you look here, you've got not only the port, the service, but more specific details about not only the software that's running, but the version of software. So why might that information be quite powerful to either a legitimate penetration tester or a malicious party?
If you know what it's running and the specific sort of version, so Samba, SMB, 3 point something, you know, if there's known vulnerabilities out there for that specific service, you know, you can kind of narrow down your scope, essentially. You're not looking at every single one vulnerability that's out there and chucking everything at this service. You can really like narrow your scope and go, right, okay, here's 10 vulnerabilities that I'm aware of.
Yeah. Definitely, yeah. I mean, that's it. So suddenly you're focusing down, aren't you? So whether it's Samba's here, or you know, ironically, the very secure FTP daemon version 2.3.4, which, as you can imagine, it's on this list because it's not secure. Now, this is a scan of the Metasploitable host, which was created many years ago to sort of help demonstrate, you know, a number of how ports and services and what they offer can be you know, readily exposed and taken advantage of. But there's so much information, and you know, when you start the learning process and the journey, you would be working through these one at a time, you know, going through, right, is there any problems with this service, either specifically with the version or just generally with the service. Now, FTP suffers sometimes from having, you know, an anonymous access enabled, quite a simple check to do. Again, comes back from the good old days when people trusted everybody on the ARPANET, but it's one of those things that can be sort of taken advantage of, and just having it in your locker is a good thing. Then you basically work through each of these services, trying to see, you know, what interesting things. Which is the point I was making, is why Nmap is such a powerful tool. And again, you can run Nmap in a really basic way. If you run the command nmap followed by the IP address, though, you wouldn't get this information. All you would get is the ports and the service. So this is why knowing how to run Nmap properly is so important, because if you run some good Nmap scans at the start of your test, you're going to find a lot more information. Additionally, you know, the standard Nmap only scans the top 1,000 ports, the most common 1,000. But there's over 65,000 ports available on TCP and the same on UDP. Although I wouldn't suggest running an Nmap scan against 65,000 UDP ports unless you've been specifically asked to do that, or there's a reason for it, because you'll be scanning that for a very long time, as UDP is a much slower protocol and takes a lot longer for a scan to perform. But the key point, as I say, is that knowing how to use the Nmap tool is critical for the things we're going to do later, and generally for testing. So just a bit more background here. You know, the reasons you're going to use it is, you know, it does network mapping, so it finds out if hosts are active. It can do that through a few ways. It can send ARC requests, it can send pings. If you think things aren't responding to pings, you can force it to run an Nmap scan without pings, and it will just scan the port range even though a ping wasn't received. It does port scanning, as you've seen, tells you what ports are open on certain systems, and then can do service and version detection, so trying to find out if, you know, FTP is there, and if FTP is there, what is running, what specific version is running there, and even operating system detection. It's reasonable operating system detection. It tends to go hand in hand with the service and the version as well. So there's a few tricks the Nmap has when it comes to finding out what the operating system version is. That's to do with things like time to live values that come back from the server. But then if it wants to get more specific, it needs ports open. So if it notices port 445 is open and port 445 has, you know, SMB enabled, and the SMB service actually leaks some information, Nmap's going to give you a much more accurate sort of representation if it's, oh, I think it's Windows Server 2008, rather than if it can only just grab, you know, the time to live value, where it's going to have to make it very generic in terms of its what it's determined the operating system to be. So some specific scenarios. This list is not every list, every scenario there could be. Ultimately, you could test for open ports on the firewall, on kind of the outside of the network. You could perform scans to determine, you know, what applications and services are available inside the network. Is anybody running something they shouldn't be? Determine the versions of services installed in your demilitarized zone. So, you know, if you've got a DNS server, if you've got a web server, if you've got an FTP server that's open to the public on public internet, they can have a look there and see what, you know, what's going on. You might want to look for specific ports that are available, you know, file sharing ports. So, you know, unfortunately, when WannaCry was running around systems causing mayhem, you know, that would have been a point where maybe you want to go around your network and see actually which services, you know, which SMB services are available, and are they version 1, are they version 2, you know, what's going on there, and use that as a way to sort of get an asset register potentially of what services are there, and generally unauthorized servers and services. We once did a penetration test quite a few years ago now, and when we were doing some scanning, and we came across this CCTV box. I think it was it was responding with the Korean language at the time. And we spoke to the IT manager, and he didn't know, because I have no idea what that box is. I'm like, okay, that's really scary, weird, and interesting all at the same time. So we helped him find out the IP address, worked out which switch it was connected to, and then they were able to investigate, and I think they found out it was a legitimate server service that they just didn't know existed. So it wasn't some malicious service placed there, but the idea is it's good to know what's going on inside your network, especially when some, you know, employees want to get on with their job. So maybe they will install things and place things on the network that you're not aware of as well. But yeah, Nmap, it's been around for many, many years. It's a great tool. Loads of people use it. It's probably one of the first tools people use when they're doing penetration testing. But the key point I'm trying to make here is it's kind of like reading the manual, right? Understanding how Nmap works and realizing that when you run an Nmap scan on a virtual network of 10 hosts, you know, on a local network where you're running a virtual machine, Nmap will perform brilliantly. However, when you run Nmap on a large corporate network, or you are running Nmap over a VPN or through a jump box, you're not going to get the same nice Nmap results. You're going to get problems. You're going to get Nmap lagging. You're going to get it getting stuck in a loop. So the idea is to understand how to use it properly. So there's an option in Nmap called Nmap-A. Does anyone know what that option would do with Nmap?
I'm guessing scan everything.
Everything.
Scan everything. It's brilliant. It's a Hail Mary. Yeah, it tells Nmap to to scan everything, do version scans, do script scans, do operating system scans. You know, do all the things. And you know there might be a reason for that, but the point is you need to know what the scan is, what the scan's purpose is. I'm sure Thomas is aware of several jobs that we've done, that if we ran Nmap-A's, we'd either never complete the job or we would end up breaking a lot of things. And the idea is, was that sorry?
You wouldn't be invited back.
Exactly. Yeah, that's the best. The best way to tell if you did a bad job or you upset people on the test by breaking things is, you don't get invited back. But yeah, and so Nmap-A it exists. It's a feature, but you might not want to always use that. So you know, there's things like you can run it. You know, I mean, no one's ever going to try an Nmap scan on a /14 network. It's gonna take a long time. And it's little things like breaking the Nmap scan up into smaller chunks. You know, knowing when you need to scan all the ports, knowing when you don't need to scan all the ports, knowing when you need to use the version scan, knowing when you need to use the script scan, and being much more methodic and professional about it, really. So again, mistake there. Please don't Nmap with -A. Not please don't. Please don't Nmap with Nmap-A, because generally you're not going to get the results that you want. Because Nmap has all these amazing options. This is the Nmap help page, and there's just so many things in here that you can use. It's helped me massively. There's even debug tools in there. So if your Nmap scan gets stuck on, say, 70% and you're worried about what's happening, you can actually use debug by pressing the D on the keyboard, and it will show you what's going on underneath the scan. So you can actually understand if the scan's got stuck, if it's stuck in a loop, or if it is genuinely just still scanning that host and it hasn't broken. As it's working, different ways of outputting. We have a few tests where we have to limit the number of hosts that we scan consecutively. So things that you can do around timing and performance, they can really help you in not running on 20 different hosts at the same time. If you need to do one host, max host, you can do 1 or 2. You can speed it up, slow it down, all those things, even little things like being able to provide it with a list of IP addresses rather than a range. Come on to it shortly, but scanning specific ports as well. Either telling it a specific port, a range of ports, specific UDP ports. There's so many different things that you can do, and including script scans, and not to be forgotten, the output, so important. If you run an Nmap scan, and that Nmap scan takes a long time to run, you need to make sure you get the output of the scan, because if you don't output the scan somewhere and the scan fails, or your system crashes, or you accidentally close the terminal, your results are gone. And if you spend an hour or 2 hours scanning those IP addresses, you're going to have to start again, and that's not fun for anybody, especially when you have to tell probably the person who's working with you, I'm sorry, we've got to keep working now till 7-8 p.m. because my output has failed. So yeah, just trying to be aware of the options to try and help you there. But yeah, basic Nmap usage is typically Nmap, scan type, any type of options you need, followed by the targets. I prefer to put targets in a text file and run them like that, but you can do different ways. You can give it a range of IPs, you can give it wildcards, you can give it subnet masks and things. There are different scan types, sort of SYN scans and connect scans and UDP scans, different ways of functioning. The default is a SYN scan. And it tends to be much faster than a connect scan, because a connect scan fully connects on each handshake. Other options that are interesting is a fast scan, if you just need a really quick way of determining the top 100 ports on each system that you're scanning, or you can tell it specific ports that you want to scan as well. As I mentioned earlier, little s, big V, a service and version detection scan. So if you run SV, it will automatically do a SYN scan, which is nice, relatively fast scan. But what it will do, it won't just find the ports and the services, it will also give you the versions with all this nice juicy information, like a little webmin mini server 1.550, which may or may not have several vulnerabilities inside it. Additionally, the others are not looking that great either, to be honest with you, especially this Apache J server. Not giving you guys any hints for the environment there, but there's some interesting ones there as well. A few more Nmap options I'm just going to mention. So say ping scan is just to ping all the hosts and see what's there. It doesn't work so well if the hosts are not responding to pings. If you don't want to do a ping scan, the -pn option will cause you to not run pings. However, it will now cause the scan to just scan every single IP on the number of ports you've suggested. So if you're using a basic scan and you use -pn, it will scan every single IP address, the top 1,000 ports, regardless if it responded to your ping or not. So again, it's a time thing. However, if you're on a local network, you have ARP as your friend. So ARP requests are much more accurate than pings in terms of identifying if a server is there. Not 100%, because you can still decline ARP requests, but if you're doing that, you're making that server or system unavailable to anybody. But it can be done. We've also got -p-, which is all ports, so all 65,000 and odd ports there that will scan for them. SU for a UDP scan. Again, would not recommend SU with -p- unless you've been specifically asked for it, because it will take forever. Specific ports that you want to scan, you can do that with -p and then followed by the port number, and you can have multiples there using a comma to separate them. VV gives a verbose output. I like it because it gives you more information. It means that when Nmap finishes, it will provide as much information as it can after the scan. Last few, --script is to invoke a script. So Nmap has a number of scripts that it can run. For example, it has a script that will check for eternal blue on an SMB port. It has a script that will check if default username and passwords are being used for a MySQL server. So you can invoke specific scripts as well to aid with your scanning. The output, as I mentioned, really important. I'm a big fan of -OA, because what that will do is it gives you 3 outputs: an Nmap output, a GenMap, and an XML output. And that's great if you want to, either do some grepping later on, looking for some things inside the scans, or actually parsing them into another tool if you need to do that later. And last one, loading from list. I like to have a list of IPs that I'm working on, and sometimes if I have a very big range, I'm going to split them up. If I've got, 128 IPs, I might do them in batches of 16, because if one of the scans fails, I only lose 16. I don't lose all 128 potentially that's running. So finding the right balance there is key. Last few, version intensity is like VV, but just you can be more specific. Top ports, so if you don't want to scan 1,000, if you want to scan more than 1,000, but less than 65,000, you can place a number in there like 30,000. DNS servers, if you want to say, actually use this specific DNS server, you can do. You can work the other way and tell it to not scan certain ports. If you need to spoof your MAC address, some MAC filtering, you can do that as well. As I mentioned, debug is a favorite of mine when things are going wrong. You can either specify at the start of the scan, or once a scan is taking place, you can just press D on the keyboard and it will actually increase the level of debugging that's going on. Do be careful. If you press debug too many times, the debugging gets really intense and your screen will just be littered with debug messages that come along. Here's an example of debugging action. So what you can do is you can actually see what Nmap is doing. So you can see that we're actually scanning. It's found this server, this port 8180 on this IP address, and it's going, okay, that's good, but what service is it? And then these lines here are showing it making different requests. So that one there, that's a probe there to try and find out what's going on there. And then down here, because this scan will be running multi-threaded, it's doing the same thing, but it's trying to work out, what is running on port 445. And then here it's checking what 10,000 is. And then it gets a match. So we can see here it's actually matched that. Let's go for this one down here. That that on this IP, on this specific host on port 445, it feels right. Yeah, we've matched that with SMB, I believe, and it's a Windows XP box as well. So it's where the specific probes are getting their requests and results here. Here it's found it made a request on port 80, and it's found that it's an Apache server, but it's 2.2.9 and PHP as well. Nice old version of PHP there for you as well. So yeah, so as I say, I just wanted to give a bit of an overview of Nmap. I know a lot of people understand and know Nmap, but just so you get a good feel for the depth and the things that you can do with it. I've covered a few just there, but there's a lot more that's available. And what you'll find is the more testing you do, the more requests you get for certain scenarios, and then the more you have to dive into the Nmap manual and see what you can find out as well. So a few tips, map the IPs. Every single port is an opportunity. It's a potential vulnerability. Yeah, fingerprint those services because it's so important to know what's going on there. Fingerprint the OS and find and check vulnerabilities through scripts because that is so important. So here's a couple of examples of, I would say, more realistic Nmaps. So I've got an Nmap scan here running on a specific IP address. I'm actually doing a full connect scan with a version check. I don't want to use DNS resolution on this one. I've actually done what I said you shouldn't do, and I've done a -A on that one because I'm just scanning it against one specific host. I'm doing all ports, and then I'm outputting that to a file that I've named correctly. And I would stress you always name your Nmaps outputs correctly, because if you don't, 2-3 days later after the test, when you're writing your report, you're going to get frustrated when you can't remember which output relates to which scan, and you've got to go into the scan to look at the IP addresses, and it can just get a bit frustrating for you. So always name the files with something that you remember if you care about your future self, not getting stressed with previous self. The bottom one is the same, but is for UDP, but also doesn't include -p- because it would take a very long time. So I'm going to stop there, guys. So I'm not going to do the Nmap scripts because I think that's enough Nmap for now. So what I'll do now, we're going to get into something more interactive. I'm going to come into the stuff that we're going to do about our services. So if Jay's watching, just cut this, Jay. This doesn't need to be in there until now. So on to the next part, we're going to look at some specific services. And a lot of people, when we go through this, always think old technology. Why are we covering old technology? That's because old technology has a habit of sticking around for a very long time. It may become less and less prominent. It may reducing its market share, its size, but it kind of always seems to stick around. So think about SMS, as a technology. It's very old now. It's so old you can spoof SMSs by using a simple little API to send text messages to people that you pretending to be somebody else. And the same with systems and networks. Old technology exists. It sticks around. There's lots of new technology, and new technology is exciting and it's fun, and we do a lot of testing on it, and it's great. But every now and again, we get brought back to old technology. And we'll have someone will be doing a test. I think Luke was doing a test a few months ago, and he came across some really old Adobe software, and he was like, "What is this Adobe software? I've never seen it." Turned out it was a really old version of I want to say Cold Fusion, but I might be wrong there. And after a conversation internally, we worked out what the issues were, and he was able to exploit it because it was so old and it existed on a publicly facing server, which wasn't great. So old technology exists, new technology is great. But I just wanted to sort of lay that down before we go into the old technology, and you don't accuse this course of being a course from the 1990s. So one of the really old technologies is something called Finger. Now, the Finger protocol was invented. It's just a really, really simple tool to be able to check if somebody else was on the system. So the idea would be that maybe, I guess in a university, you wanted to see if your friend was logged on, or if you wanted access to a system, you might want to see who's logged on so you didn't take up all the resources. Or you might just want to see if John's in the office because you want to go grab lunch with him. So you could use the Finger command to see who was logged on to a system at that time. Really simple, really, really useful, I guess, at the time. Really basic kind of instant messenger, Slack is the little green light on version. But the interesting thing is if this technology leaks onto anything more modern, more useful, more nowadays, it can be used to see not only who's logged in, but get their usernames. And if you can get people's usernames, there's a lot of things you can do with that. You can use it to build password attacking lists. You could use it with other attacks that we're going to look at later to take advantage of them. So it's an information leak that's no longer required. Don't see that often, but we do see it. It's kind of sometimes quite fun when you see one of these old technologies, because you feel like, oh, great, I can really test it and show how bad it is or how bad it was. And I say it's just really simple, using the Finger command to at the server that you're going to think, and it will come back to you and work like that. So in line with the Finger command, we're also going to look at Berkeley R-Services. So these guys, old services from a long time ago. They have different purposes. You have things like Remote Shell, which runs on TCP, which runs on 512. Generally, the names explain what they do. This is used to log in. This is to run a remote shell. They kind of have the same purpose in a way, except RSH allows you to do command execution remotely. Our logging allows you to log in like Telnet, really. But then once you've logged in, you could do sort of command execution as well. And a lot of these old services, the authentication was based on source IP addresses. What, I hear you say? Why would that be? Well, this was because in the 1970s and 80s, networks were very, very sort of nice places to be, I guess, and you could trust people on the network that they weren't going to use these things to log in and do bad things, unlike nowadays. It's probably quite the opposite. I think you put a server on the internet and within about 20 seconds you're getting bombarded with SSH logins and everything else under the sun. So the times have changed. So having these available on an internal network particularly are not a good thing, as you can imagine. You've also got our users and AHU. Again, you can, I think, imagine what they do. They list the logged on users on the remote hosts. Yeah. So what they do is they go in there and say, right, who's logged on to this machine? What are they doing? And again, it's kind of thing that leaks information that can be used if someone gets inside. Typically, we don't see these services available externally on the public internet, just to be clear. But if we do see them, I mean, if they were on the public internet, it would be dire. If they were, they'd be getting exploited immediately. However, if they exist normally, we see them internally. And that's the kind of thing where if someone has breached the perimeter of the network, you might say, well, it's inside the network, it doesn't matter. The problem is it's a stepping stone. It's an information leak. It's an opportunity for someone to take advantage of that network or that service that's there. And one of the reasons that they're so bad is their access control. The access control that they have isn't great. So you can have access control files, and these access control files could be system-wide or per users. So you can have a .rhost file in the user's home directory, or you could have it system-wide in the etc host.quib file. And inside these files, if you have certain entries, it allows people to log in if their username matches a certain parameter. So if you have sort of host, it's going to allow a host to log in with the same username. So if your username was Bob and there was an entry on this system for Bob, if you try to log in as Bob from your machine, it will go, oh, it's Bob, he's just on a different machine. I will let him in. I go back to the finger protocol and why actually finding out the usernames on these old systems is bad. Because if you find the finger protocol or finger service on a system, but you also find our services available, you might be able to pull them together to be able to log in. And if you can log in, that gives you access to the system. That's not great. And as I say, within sort of the CREST syllabus, our services are part of that. So it's a really good thing to know and understand and be able to do really. Also professionally, if you ever come across it in the wild. So now we're going to move over to an exercise. So nice simple exercise, guys. What I want you guys to do is to go onto the network, and I want you to do an Nmap scan, and I want you to find any systems that have finger enabled and any R services. And what we'll do, I realise I shouldn't have shown you that one. Pretend you saw that slide. What I want you to do is to log on, find me the finger service, find me the R services, and then we're going to see if you can put what I've just said together to break into the machine. How's that sound?
That's fine.
Reckon you can do it?
I mean, for sure. You might want to specify the IP range to go against.
Yeah, that's
good point. What we're going to do is the IP range will be, I'll let me log on here and I will, yeah. So what you guys want to do is we're going to be on 10.0.57 and we'll go from 1 all the way to 10.0.57.35. So within that range, see if first person to come back and tell me the host that has the finger service and any R services, and then I'll confirm it on my end when you've come back and told me.
Well, the names on one.
Oh, you've jumped ahead, Kieran. Excellent. Right, I'll run this myself, and then we'll see what I get. Obviously, you can imagine this is part of a. We're going to use finger, then we're going to do R services. So there's one specific host I'm looking for. Actually, say press space, and it will tell you how your scan's doing. So it's found 12 systems on mine. So here's an example of it looks. If I press D now, it should.
If I'm correct, it should be 12 that's got the R service and the finger.
I believe I can confirm that that's probably it. So I put debugging on level 2. You can see actually that it's looking at port. Actually, it's looking at port 79 at the moment on number 12. So it's trying to work out what it is. So it hasn't fingered, but it's fingered yet. Is it Java RMI? No. It's struggling. But again, this is just nice because if you just press space when your scan's running, sometimes you'll see the time going up on your scan, and you feel like, oh, is something broken? Whereas now, at least I can see that what's happening is, and now it's finished, is it was struggling to find the service. So let's have a look here. All the way up here. I think, yeah, you guys clocked that we had this one as well as which one else? We had 12 and, this one, 11 was the other one. So yeah, whereas I'm more interested in this one because we've got finger and we've got some R services as well. So what would we do now I want to look at 12 in more detail. what should we do? What should we run to try and find out who's running on 12?
So we want to be using finger to enumerate the users.
Indeed. So let's use finger on number 12. And just like my slides, you can see it's come back with 3 different users. We've got Rodney Piper, Shelley, and Rex. So three different users there. And with this machine being so old, we would now maybe turn our attention to the R-Services. So what we can do is we could just try and log in, directly, just to see if there's anything that's going on, and it prompts us for a password, which is not great. So we need to sort of have a think about, say, other ways that we might be able to log in to that system. I'll try our login as well. I get prompted for a password. However, as we know, some of the sort of users of this system, what we can try to do is, moving on to this slide, is we can try to see if the R-Service problem exists. So what we're going to do is we're going to change our name to the users that are on sort of this operating system. So what I'm going to do first, I'm going to have an attempt. Let's go for Rodney. I'm going to do a really simple add of Rodney, and then I'm going to switch user into Rodney. So I am now Rodney, and I'm going to try and do the same process as before to log in now as Rodney, and I still get requested for the password, which I don't have, which is not great.
So at this point, we're assuming that we haven't got any idea about an R-host file. Just assume that somebody might have one.
Exactly, yeah. So the R-host file is local. So the only way to validate that is to try to get in. So if you don't have a login, we've basically got to try to get in by just by sheer attempt and luck, really. So I'm going to try and add now user add roots. Oh, okay, so I may have done this before. So Shelley roots already exists, so just ignore. You didn't see anything there. But I'm going to switch over to Shelley now. And if I now try to remote shell into that system, we get logged in as Shelley roots. So we're into it. So who am I? I'm actually now Shelley roots on the system that we've logged into. And we can have a look what's there. Oh, there's a trophy. Yay. So we've kind of small little challenge, but we've completed it. And if we were to do ls and la to look at the hidden files, you can see the reason that was all possible is because of the R-host file that exists there. So again, it's just to really show that how a leak of information and some old services can lead you to know or to have a suspicion that something's not right. So you would just basically try to, once you've found users on that system, you would just try to log in using that process. And I did it manually. You can script it. There are tools that are able to do that for you as well. And several vulnerability scanners will do that for you. However, you need to give them the usernames because they would probably guess Shelley roots as a username. And moving on, in this kind of area, we've got remote procedure call or open networking computing. And the idea, again, based back in probably the 70s, 80s, is this allowed a program to call a procedure in another address space or another host, another system. So you have one system that wanted to invoke a command procedure somewhere else. So when you couldn't run it all on one nice box at home, you might have to go to a different system, different service. It was originally developed though for network file system to allow one computer to interact with another. So the way that you would find this on an older system is you would have to run the command. If you run the command RPC info against another system, it will tell you if there are any RPC services available. And in this case, what's come back to us is the port mapper itself, which is kind of the program where we're asking, so what are you running? But we've also got mount and NFS and NS and nlock manager. Now, the one I'm interested in is network file system. Because network file system is potentially a mountable resource, and if we can mount the file system, we can probably cause some trouble, can't we? If we could mount the file system, what do you guys think we could do? If we could mount the file system of a second computer onto ours, what does it give us the ability to do?
You get to read whatever documents and things are in there, depending on what permissions are set.
Yeah.
You could, realistically, if you've got enough permission, you can write your own things.
Definitely, yep.
Certainly use it for a path to privilege escalation.
Indeed, that's it. Yeah. So when you mount the file system, we could do a few things. We could potentially try to add our own SSH keys, so we could log on through our SSH. We could then run, if we have certain permissions, we could try to see if there's any local privilege escalation available. Sort of using all the different ways, based on the fact that this is an old service, there's probably a kernel vulnerability in there that we could take advantage of, to escalate the privileges. But first, we've got to find that system. But NFS, another old protocol, but it's a service that it's used. You know, it was last updated in 2016, so this is not like the R-Services exactly that has been kind of made redundant. I would say NFS isn't as common as it used to be, but it still exists. It was originally developed by Sun Microsystems before, in the end, Oracle have gobbled them up. But it's a pretty robust protocol. I found it did the job. It did what you needed it to do. Allowed you to mount file systems and access shares and things, but like anything, if it's poorly configured, it can be taken advantage of them. So within NFS on the server has its file system potentially available to export. If it's exported, you can mount it onto your local system, and the way that it's configured is critical. So does it limit you by IP address? Does it limit you by access in terms of, do you need to provide some credentials? Is the file system read only or read and write? Other things like no super user ID or no exec or root squash, which doesn't allow you to be root on the other system as well. But let's see what we can do. So the key point here would be to use a command called show mount. So show mount-e, and I've gone to head, sorry. What we need to do first is we're going to do RPC info. And we're going to basically target our so what we're going to do is we're going to do RPC info to target our specific host and see what we can find. And just like my slide, you can see we've got NFS is available. I believe though also, if we were to use Nmap, it would also give us the same result. If I actually use Nmap with a script scan, the built-in script scans, doesn't give me anything today, no problem. But anyway, this is our target. So what I'm going to do is I'm going to use show exports -e, which is a command that will ask the remote system what the file system is offering. So I'm going to target that against that host.
Sudo.
Hang on, I'm gonna. I think it's show mount. Scrap that. Yeah, just delete that. Show mount-e, and then what we're going to do is show mount-e, and what we're going to do is we're going to have a look and see what exports are available. We can see our friend there, Shelley Roots, still available, and we can see Rex Hamilton. Now, a bit earlier I mentioned that the way this works is it can be restricted by IP address. So based on the output, guys, what do you think? What do you think we can? Do you think we can mount Shelley Roots's file system?
No.
No, because we're not coming from .12.
Correct. Yeah, .12 is the actual local or the system itself, so that's good. What do you reckon about Rex?
That looks like it's wildcarding, so just any IP, it'll just allow.
Yeah.
Exactly, yeah. So we can get Rex. So give you guys a quick challenge. What I'm going to do, this is the way that it works in a lot of scenarios, is I'm going to tell you that obviously on this IP address, Rex Hamilton's file share is available. What I would like you to do is take my example command here, mount of the file system, to mount that file system and tell me the value of the trophy. Does that make sense? So you've got your target. We know which system we need, but in most cases, what you find when you're coming across new commands is what you've got to do is you end up getting given something like this, where it doesn't tell you the exact command, but it gives you enough of an indication. So the mount command, we need the NFS system, and we're going to try and mount it with read and write capability. So the last thing you guys need to work out is, what the IP directory structure is and the local mount point. So praises, no prizes, for whoever can give me the trophy first. Let's see how you do, and then we'll compare trophies with my own when you've accessed it.
Save you some hassle. You should definitely use sudo with show mount if you're not as a root user. Just put that out there.
I've done my old sudo I though. I've taken perpetual root, but yeah.
I was thinking for the other guys that have just knocked Callie up this morning. So.
Are we looking for the trophy or the Netflix creds?
But you have to get the Netflix creds. That's the privilege escalation challenge. I guess you got the trophy, Kieran?
Yeah.
What we got?
NFS_mounts/4/all.
Oh, that's a trophy value. I didn't know that. I thought all the trophy values were specific words. Interesting. So let's do it ourselves. So I'm going to mount. Got to get this command right. Rex Hamilton. No, Hamilton. There we go. We're going to mount that onto MMT, and do I realize I probably made a mistake with it? I'm going to try it. Oh no, success. So let's go to MMT, and yay! Just like Kieran could see, we've got our trophy, which is NFS. I get it now. NFS mounts for all. Yes. However, this is one for anyone who wants to play on the network. You have permission denied for your Netflix creds. So that will be because Netflix creds is linked to or owned by the root account. And at the moment, although I'm root on my computer, I'm in Rex Hamilton's system. So here would be a challenge for you to try and get an access through privilege escalation, which we're going to leave you to do and pick up later on in a later class when we do privilege escalation.
So first of all, to understand cross-site scripting, we need to know about JavaScripting. So JavaScript is all developed by Brendan. It runs on the client side. By client side means it runs on the web browser of the client who is actually viewing the website. It adds interactivity to HTML pages. Now, what do I mean by interactivity is if you go to Facebook and you try to send a message, in a traditional sense, in old times, when you send a message, the whole page will get refreshed, and the new contents will get uploaded at that point. But nowadays, if you go to Facebook, you try to type a message, you click on send, it immediately appears on that page without refreshing it. This happens because of the JavaScript frameworks that are working in the background. Have any of you guys heard of or used Angular or React.js before?
Heard of it, never had to actually use it.
Okay, cool. So no, okay. So they are quite cool. They make your life really easier when you're trying to make an interactive content and you want the website to change the content on the fly. So we're going to talk about that. This is the actual problem. The actual problem is the browser have to trust the HTML, because the HTML is used on the website to refresh the content. If browser does not trust your JavaScript, the content cannot get refreshed. If it cannot get refreshed, you would not see the message on the page that you have just posted unless you refresh the whole page. It is interpreted at the runtime, as we know. So how does it work? In order for JavaScript to work, we use some script tags. It is a opening and a closing tag that is placed within an HTML page, and whatever you put in that tag will be treated as JavaScript. Now here is a small example I put in here. So imagine you want to show a current date on the page. You can write this simple JavaScript, which is script document.write, and then you type date inside it. Now, if you want this date to update every second, you can write a bit more script, and this section of the page will be updated every second, every 5 seconds, however you want it. Instead of you going and refreshing the whole page, you just need to update that bit of the section. Does anybody know what's the advantage of doing that? Why do we want to refresh only the bit of the page and not the whole page?
Save bandwidth, maybe?
Save bandwidth. What else? True. And it is a lot quicker. So the response time is extremely quick. Now imagine you are viewing a website like Facebook, and every time you open the page, it have to download all those images that you see on it. How long would that take? Just because of updating only the bits of it and caching the images within the browser, it makes your experience really good, and it actually loads the page extremely quickly. Now, when we do our tests, the first thing I try to do is pop the box, and this is how you would do it. It's a simple way of actually proving that the website is vulnerable to a cross-site scripting attack. All you do is you start a less than sign and type script, greater than sign, and then you type alert, and in the quotes you can type anything you want to be appeared on the box itself. And you close them, and then you put semicolon, and then you close the script tag. And when you refresh this page or run this code, it will show a pop-up box on the page. That's the simplest form of a cross-site scripting attack that you can execute. When we are testing because it's very simple, just one line. When we are trying to test the websites, we do that all the time just to see if they are vulnerable or not. Let's dive more into cross-site scripting. Now we know a bit about JavaScript. We know how to get a pop-up box. We know how it puts the alert in front of you. Now let's talk more about it. How would you do it, and how does it work? So as I was talking earlier, the dynamic contents on the websites that are personalized, the website have to load them. If you change, imagine if you're changing your profile, and every time you have to click on submit and the page goes back, the whole page goes back to the server and comes back. It's a waste of time, it's a waste of bandwidth, and it takes a long time. It's a lot quicker when things are loaded quickly. You all probably shop from Amazon. When you go to Amazon and you try to add a product into your basket because you want to buy it, imagine whenever you click on add the product, this refreshes the whole page. You will not only lose where you are. If you scroll down like far beyond down the page, you will lose your place, and also the page will hold refresh. You will take time, will waste your time, waste your bandwidth. But because it immediately adds the product into the basket using JavaScript, it's really quick. The problem comes in because of this JavaScript. As we were talking about it earlier, because the browser have to trust the JavaScript, and the JavaScript runs locally, there is very limited means, if the inputs are not sanitized by the application, there's very limited means that a website can implement to protect those clients. We will talk about the mitigation techniques in a minute, but when the code comes from the website, when the code is reflected from the website. By reflected, I mean you make a request to the website and that request comes back with the response to you. When it comes back to the response to you, the browser have to accept it as it is. The browser will think because it is coming from Facebook, because it's coming from Amazon, it have to be a legitimate request. It does not care if there is a code in it that will be executed in the browser and that will harm the machine of the client. So it's a simplified problem. Browser has to trust from site it makes HTTPS or HTTP requests too. And if there is insufficient sanitization, if the server or the application is not sanitizing the inputs and not filtering the inputs properly, then when it comes back to the client, it will just execute. So there are two main type of cross-site scripting attack. One is reflected cross-site scripting attack. One is stored cross-site scripting attack. So the reflected it when somebody gives you a link. Let's say you got a phishing email that says you're from Outlook that says your password is expired. Please click on the following link to reset your password. And an attacker found a vulnerability with Outlook, and they create that link with the code at the end, a cross-site scripting code, and send it to you. You click on that link, and when you click on it, you will go to the website, and the script will execute within your browser. And we will look at the examples, what you can do with it. It will, in the case what we looked at, it will create a pop-up box, it will steal your cookies, right? In some cases, it will completely change the whole website, which we look at in a minute when we will do the demo. So you can do a lot with reflected cross-site scripting attack. In the case of stored cross-site scripting attack, an attacker actually found a vulnerability in a website where he can store the information that is viewed by other client. For example, there is a forum like Stack Overflow, let's say, and you paste a comment on Stack Overflow, and you view them, you ask a question, you view the answers, and imagine if there is an attacker. He posts a script, a malicious script in one of those comment boxes. When you will view that Stack Overflow page, you will be compromised, and that cross-site scripting attack will execute within your browser. So that's the simplest. We'll talk a bit more about them, but does it make sense for now?
Yeah, makes perfect sense.
Perfect. So let's talk about reflected cross-site scripting attack. So an example is you go to a website, that's in our case example.com. You want to search for a product, right? So the code for this form that is showing on the page here is this. You add script alert XXX, which, as I said, is simplest form to execute a cross-site scripting attack to check if the website is vulnerable to those attacks. You put that in a search box and you click on submit. Perfect. So there are two types of requests that you can send across that we will be concerned with in this cross-site scripting lecture. So there's a GET request and there's a POST request. In the GET request, the content you are trying to send to the server is actually added to the URL. In the POST request, the content that you're trying to send to the server is added to the body of the page. So as Credan said, the URL will look something like this, which will have www.example.com, search.php, and the search phrase is what you have added in there. Now, an attacker, because he found out this website is vulnerable to a reflected cross-site scripting attack, can send this link to his friend and say, can you check out this product that I have seen? Can you check out this product on Amazon or any other website where he found it? I've seen that's quite cool product. And when somebody would click on that link, the cross-site scripting attack will be executed on that browser, on the browser of the client. So the attacker have a control of the script tags that have been added there. Once this URL is called, once the client, the victim makes it to that URL, in the background, the PHP actually grabs that request from here, tries to search in the database, if it finds it, if it doesn't find it, and then it sends it back to the client, right? Like Echo, you search for, I've seen several websites, and I believe you have as well, in which it tells you exactly what you search for. So In this example, the PHP is actually showing back to the user that they have searched for and then the search term. But because you have added a cross-site scripting attack in your search term, this will execute here. And what do you think is going to happen? It will show a pop-up box like this on the client machine. So in essence, if we summarize it together, what is a reflected cross-site scripting attack? Attacker makes, so the victim HTTP request includes a malicious script. He can do that by, as I said, sending a phishing email. He can do that by adding the URL to a forum as a Stack Overflow or any other place that they think that people will come around and click on those links. Victim needs HTTP request victim sends HTTP request to vulnerable website. When victim clicks on that URL, in this case, that URL that you can see on your screen, when victim clicks on that URL, he will go to the server to get the response back from the server. It gets reflected, the URL gets reflected and the contents get reflected from the server itself and come back to the victim and gets executed on the victim's browser. The key point here is it's a trusted website. The browser trusts that website and the victim trusts that website because they use it. And that website ends up executing a cross-site scripting attack on their machine. Let's talk about stored cross-site scripting attack. In the same example that we looked at a minute ago, how do you do reflected? In the same way, you can do a cross-site scripting attack. If you have a place on any website where you can post a comment, and then in our example again, you go to example.com to post a comment for a product or a review for a product. Let's say you left a comment that is same as we used before, script alert XXX, and then you put this comment within this box. When you submit it in the same way, the PHP will grab that comment, assign to a variable, and then add that to the database. Now, imagine that this content has been added to the database and you or somebody else visits that website. So it will execute that JavaScript on the page because it will make a request and it will bring that data from the database and it will try to show that data on the actual page, and that will execute a cross-site scripting attack, and then you will see a pop-up box like that. So like we talked about the reflected cross-site scripting attack, how does stored cross-site scripting attack works in terms of the steps. So attacker inserts malicious script into a vulnerable website. Victim visits that vulnerable website and the malicious script is executed on victim's browser. It's very simple. Whenever somebody visits the website, it will get executed. Which one do you think is more dangerous, reflected or stored? Stored. Which one do you think?
Everybody.
Perfect. Which one do you think is harder to find? Reflected. Stored is harder to find. Reflected is kind of easier to find. Like the advantage of these attacks is, imagine you are a hacker and you are trying to hack a bank, right? You're a black hat. Credentials for the clients are vested. Sorry?
I don't know if it was just my end there, but the audio was really breaking up.
It wasn't.
Oh, sorry. Oh, sorry. Sorry, can you hear me now?
Yeah, you can hear you.
Ah, perfect. So imagine that you are a black hat hacker and you are trying to hack a bank, right? Would it be easier for you to go ahead and try to hack the bank where there will be firewalls and IP tables and IDS and all those protection mechanisms? Or would it be easier to find a way to hack the clients themselves? What do you think would be easier?
Oh yeah, the clients, for sure. At least
the clients itself. Perfect.
Access, maybe.
Yes. So what you can do is you can use, instead of going ahead with $1 million, you can forget about that. You can forget about all those things and take the route of cross-site scripting attack. And whoever visits that website, you can actually get the credentials from them. easily straight to your website. And we're gonna look at in a minute how to do that. So the websites that are vulnerable to cross-site scripting attacks normally are search engines, because you will actually perform a search on the website and it gets echoes back at you, showing you what you have searched for, or forums where you post a comment and that is displayed for you and other users to see. Error messages, in this case, if you type something that is malicious and you insert it and server thinks that is an error because you have added script instead of simple text, it will send it back to you saying this is an error and you have to type the proper string. If they include your script within the error, it comes back to your browser and executes itself. That is another form of cross-site scripting attack. Forms that are filled with data, which is later displayed back to the user. Once I was testing a website and I found this vulnerability in the sign up form. So when you sign up on the website, you can actually put in your username and your password and all like things, different fields. And I put in, instead of my username, a scripting tag. And whenever I was viewing my profile, I was seeing the cross-site scripting attack executing on that page. So malicious scripts are, as we have been talking throughout this lecture, is like script, alert, XSS, script. Now the question, what if the script tags are blocked by the application? What can you do?
URL encode them.
URL encode them. What else, sir?
Break them up into like different forms of the word script.
Different what of a script, sorry?
You can basically break up the word script to use like different upper and lowercase letters. Is that?
You can. What else? Okay, so you can use image tag, as Kieran was saying. You can put a malformed image tag. You can put instead of source, and if you see the quotes here, if the quotes are blocked, if the single quote is blocked, you can use HTML encoding for that. You can use hex encoding for this. Right? You can be cheeky with the scripting tags. So if the website is configured to block all script tags, what do you think is going to happen to this one? Yes. Yeah. So when it will go through the filter, it will take the script tag off from here, from less than sign to the greater than sign, because it does not allow script tag. And when it will take it away, it will become script, right? And in that case, it's the same thing. When I will take this one away, it will become script and get executed. Now, there are other things that you can do. You can load it on the body. You can put, if the image is blocked, if the script tag is blocked, you can simply load it on the body. You can type this in the cross-site scripting attack field. If it is vulnerable, this is going to work. You can load it on SVG tag, right? You can load it on iframe. You can load it on table. You can load it on a division on a page. So there is so many different ways that you have to at your disposal when you're trying to hack a website. Now, I've seen this mitigation technique. I partially agree with it. We're going to talk about it in a minute. But the recommended techniques are you escape user inputs. You can do block less than signs and greater than signs, quotes and slashes, and then the data will become pristine and it will not execute a script. Do you guys agree with that? Blacklisting. Yeah. So that's why I don't really like it. It is a good way of stopping attacks. You can implement it, but because it's a blacklisting way of actually blocking attacks, you will bypass it. Somebody will come around with another method and they will bypass it. I always recommend to adopt a whitelisting approach in which you specify exactly what you want user to input into the field, and that gets executed or entered to the website. Now, if there is an input field that need to be added a username, right? Does it need any quotes? Probably not. That's what I thought. But the problem was when I was working as a developer, one of the guys was from Ireland and he had a single quote in his name, right? So you see a problem there. He wasn't able to log in because we sanitized, right? And he said his name is not like that. He have to put the single quote in. So then we started encoding it, right? So everything gets encoded and entered to the website and then decoded when it goes back. This is exactly what is recommended here. In a way, you encode it and then you stop it by applying a whitelisting approach, in which you say the user is only able to put alphabets, right? A user is only able to put numbers into a field, right? Only restrict to those those values that you are actually expecting user to put in. If by any means there are problems, like as I was saying, the person had a single quote in his name, then you move to this approach and then you perform the HTML encoding and encode it when it goes to the database and then decode it and display it on the website. Does that make sense?
Yeah.
Cool. Perfect. Okay. Any questions before we go to the demo?
No.
No? Does stored and reflected cross-site scripting make sense?
Yeah.
Okay, perfect. So let's see. So here's the website. Let me go to the. Okay, so here's the website. So this is on your training document. I believe this is question number.
Should be 5.
6.
Well, yeah.
That one. Okay, so what we are going to do is we are going to look through these cross-site scripting attacks on that sheet, which is web application 1. And you are going to do that on those 2 machines, right? Now, I'm trying to do this one. I picked it in the middle and I thought I'm going to try this one and see where we go with this. So this is the application. I went to the URL. Can you guys see my browser?
Yep.
Okay, so I went to 10.0.57.1.5. Now, I have tried to test these ones, put different values in them, see the error messages, what does it give me back, and just play with it, see what you get back from it. If it gets back to me, just loading. Hope it's not died.
Mine responded nearly instantly, so
okay.
They have an issue.
Okay, don't know why.
I mean, your VPN might have had an issue since you had that connectivity problem earlier.
Sorry, I couldn't hear you. What you said?
Oh, sorry. Yeah. So your VPN might have not successfully reconnected. You know, after your Zoom dropout and stuff earlier.
Okay. It seemed to be connected. I can disconnect it. Disconnect really. Why not? Okay, that might be it. Okay, getting back at it. Just put anything in there, see what happens. Does it throw back at you, right? Does it throw anything back at you? So this is how you actually proceed to test a cross-site scripting attack. You see what is coming back as an error. If there is any value that comes back an error that you have added into name and password, then you can fine-tune your attacks. So there is 2 input fields here. There's 1 here. Let's have a look at this one. Just add 1 in there because it says ID. So we're going to test what is going to happen. It shows in here. So now, as you can see, this comes in here. That means the value that we have put in the input field has been translated and viewed on the page itself. Now, what I do is when I am finding out any cross-scripting vulnerabilities, excuse me, I try to inspect. This gives me a lot of information about the page itself, about the inputs, about the outputs, about the programming, how somebody coded the website. So in this case, when I right-click on the field and went to inspect element, it took me exactly where the element is on the page. If I hover over it, you can see the highlighted on the page. There is a little script underneath it. Okay, this seems a bit interesting because the value I have added in here, which was 1, has been placed in here, debug ID 1, right? So that means if I put something else in there, I don't know, let's see that, what will happen? Still stay the 1, because I think it is only expecting integer. So put 2 in there, is coming in here, right? So now, what if I try to show or do a cross-site scripting attack? Let's do that, right? By the way, this might not work, but we are going to try this just to prove it. Okay, it's gone again. It's not coming back.
It's not actually responding very well for me now either.
No, I don't know what's happening. Let me quickly go to the VPN again. Disconnect and reconnect. Okay, that came back. Okay, so as you guys can see, I have added in the ID field 2, and then I have added script alert 1 and script. If you see here, can you guys read this here? Can you see this?
Yeah.
This script here, right? You see this here. Whatever I added have come in there. Now, as you can see, there is a single quote that appears before 2. Can you see that?
Yeah.
Right. So what if I added, and funny enough, this is already within a script, right? So the script tag is here, the script tag is here. So whatever I put within the script tag should execute as a JavaScript, right? So instead, or I can add scripts, whatever I feel like. Let's close that. Let's close the single quote and resend it. What's going to happen? Okay, inspect it again, right? Okay, this is again a part of the same string, right? Okay, so what are we going to do this time? We'll add a semicolon, right? Again, this is the part of the same string. Now, the next step would be to add, what if we close that script tag? Can you guys see that?
Yeah.
Okay. Now, this executed a cross-site scripting attack for us, right? What did we actually do? We actually typed the ID, close that, and then we actually proceed closing that scripting tag. As you can see from the URL here, we closed that scripting tag. We started a new one, right? We typed alert, and then in round brackets, we typed 1, which you could have typed anything. And then we typed in script at the end, right? So it have executed successfully a reflected cross-site scripting attack for us. Application is stopped again. I think it's something to do with the VPN. Okay, here we go. So now, the question which students ask normally is, what is the big deal? Right? If you can pop on a box saying 1, what is a big deal? Right? What else can you do with that? Any ideas?
You can inject like fake login screens.
You can inject fake login screens. How would you do that? I was looking at this, and I put some scripts for you guys together to show you what you actually can do with this, as I'm hoping that the website stays working. Let's see. Okay. Let's try that one. Okay, so what happened here? Can anybody tell me?
Has it into hidden?
Yes. So what I did is I added a script tag, another script tag, and I said document get element by ID container, which is this here. Can you see that? So this is where the whole page starts. And then I said style display to none. So what happens is this has removed the whole page from me. So there's nothing on that page. So what I'm going to do next is, once I removed everything from this page, what if I try to put my own stuff on that page? If it comes back, hopefully. Is this working for you, Ron, or is it gone for you as well?
It's hit and miss at the moment. Sort of 1 in every 5 requests is loading.
Bit crazy. Try again. Okay, here we go. So we now successfully set the display of everything to none, right? And then we started our own HTML contents and we typed in the hello world on the page, right? So we have essentially made that website from looking like this, right, which is a trusted website, trusted URL, to look like this, right? Now, if we go a bit further with this, let's do that and copy a bit more of a script. And again, hoping it works. The website is stable. There you go, right? So we have essentially changed the whole website to say you have been logged out, log in again. Right now, the code written in here, but if I inspect it, it will make it a bit easier for you guys to see. So this is the new form I added. I added a form that have a post request, and the action on that form is goes to hacker.com, right? With the username that user have put in, with the password they will put in, with the login button here that they can press. Now, imagine that the vulnerability, this type of vulnerability exists in Facebook.com or Amazon. What is going to happen, right? A customer will come to Amazon.com. They will see a page that says you have been logged out, log in again. They will put their username and password, and then when they will click, the username and password will be sent to this URL, and the hacker will have actually access to both the username and password at that point. Does that make sense?
Yeah.
Cool. Now, what else can you do with this, right? So you can change the whole page, right? But if you don't want users to know that you are actually harvesting the data, you don't want to be really visible, you are on a website like Stack Overflow and you want to execute a cross-site scripting attack on here, you can do something like this, right? So does anybody have an idea what is this going to do?
Is it going to run the PHP from another site?
Yes, exactly. So what I'm doing essentially is, because this website actually do not have any cookies at the moment that are set up on this website. If this website have any cookies or any other information that it contains and I wanted to send it to my website, I simply replace hello with, in case of cookies, document.cookie. And in that case, it will send the cookies to that website. So let's copy this one, right? And just test it and paste it here while we are doing, before we hit enter. So here is the, stop responding. Okay, just bear me 1 second. I'm going to stop. Perfect. So the script looks like this, script, because you are closing the script that existed in there. You start a new scripting tag, you type a source name, and then you can type a website, any website that you like of your choice. And then you can type the folder name if it exists in a folder name. And then you type the name of your PHP file. All that PHP file does, I type anything in here, it will take that, intercept that, and put it in a file. Anything I put in here. So it can be cookies, It can be login credentials. It can be user IP address. It can be anything, literally. You can create a keylogger in here and put it as a JavaScript and load it on the website. And in that case, it will log all the keys user have pressed on that particular website. So if I go back to the thing and hit enter, it's gone again. But just to show you, I don't know when it's going to come back, but I just ran it. So it will, I'm gone to my server and try to tail that website, which is a new file.txt, where all the text get added. It will have hello in it because the string I created is hello in that text. Does that all make sense?
Yes.
Yeah.
Any questions on that? Perfect. Okay, so the idea was here to tell you the cross-site scripting attack really are very basic, right? People do that all the time, and I think me and Thomas have competitions whenever we go to a pen test. Who is going to find cross-site scripting attack first, right? And Thomas will agree on that. About, I would say, 95 to 96% of the times we will find a cross-site scripting attack in one input field at least, if not riddled with cross-site scripting attacks. So whenever we find those attacks and we try to show that to our clients that you can actually create a pop-up box, the question always comes up, pop-up box, then what, right? So it's a pop-up box you created on a client side. Right? Why is it my problem? Right? It becomes the problem of the person who created the website or the owner of the website when the end user get hacked, when the credentials of end user get harvested, when the keys of end user get logged. Right? You can also write JavaScript to redirect that user to another page. Right? So if user comes to Amazon.com and I find that vulnerability on it, I can redirect that user from Amazon.com to my own personal website. Right? So you can go as far as you need to using JavaScript to do lots of creative things to actually compromise the client and the end user. That is so it is quite important to understand. And it's quite important to know about, and it is a part of CRT. So you guys should practice that. And as I said earlier, there are some exercises that we have put together for you guys. I believe you guys all have access to this document, which is for web application. I have done one of them for you, which is the number 6 one.